Hello everyone, thanks for joining my talk. Today we're going to talk about property-based testing. Before we start, I would like to introduce myself. He already mentioned it. My name is Bjorn van der Laan. I'm a software consultant for Xebia, the Xebia from the sponsoring from today. Working on different assignments for different clients. If you want to know more about me, then on these three platforms you can find some information. And also for the code samples that we'll see in this talk, you can find them on my GitHub. The link is at the end of the presentation, so that you can easily find it. We also have LinkedIn and Twitter I'm trying to build, so I'm trying to still find people to follow. If you have tips, please approach me during the break. Anyways, let's go to the talk, the thing you came for. This is basically the plan for today. We're first going to look at unit testing, how at least I'm used to it, maybe you as well, where we use examples to do our tests. We're going to look at, what are some of the problems that you can face with that? And then, of course, the hero of our talk today, property-based testing. How can it be used to alleviate these problems? And then also, because we're talking in a Kotlin conference, I would also like to spend some time on how we can use Kotlin to make these property-based tests even a bit more readable, mainly through, for example, extension functions. But before we get to the actual content, we're in Amsterdam today, we're in the Netherlands, and that's why I have a small question for you to see how well you are here in the culture of our country. 3 Dutch programmers walk into a bar and they order a drink. Now the question is, of course, who's paying? Who's paying? Sorry? Of course. They are going Dutch, right? They split the bill. Here in Netherlands, it's quite common if you're drinking or having dinner with friends, or even if you're going on a first date, that people split the bill. And what you would usually do is that one person pays the bill at the restaurant owner, because you don't want to have them process like this many payments, and then afterwards they send you a tikkie on WhatsApp, like a payment request, and you can all pay. This behavior is so ingrained in culture that we even have some nice apps for it. And this is an example of an app that I use with my friends. So here is a simple screen where we can declare our payments that we paid for each other. For example, this guy, Weaver, he paid 80 euros for us. Apparently we were with 11 people because I paid, it decremented my balance with €7.27, right? And then all these things are accumulated, and it also will tell you the balance. It will tell you, and here you see that I am a very generous payer. I'm on top of the list, so probably they pay next time. But the fundamental characteristic of this app is that if you have all these balances and you would all settle them, then it should add up to 0. Because else, money would be created or money would have been disappeared, even worse. But what if we would want to implement a function like this? So if we would want to build our app in Kotlin, then a simple implementation could look like this. And it will also be our example for this talk. We will probably start with some class to model the person. It can have some characteristics. We have a name, we have an age, some email. For example, if you need to send some notifications, hey man, it's time to pay. And we also are talking about money, about euros. And in this case, we can just use type alias, alias float as euro. Now, then we can start implementing our function. So we would probably create a class, the payment settlement service, which has a field, just to keep it simple, a field balances, which is a map, and that map maps a person to its balance. Simple enough. And it also will have a method, so you can actually settle these payments. This is a settle payment method. It has 3 parameters. First one is, who paid? Second one is, who did he or she paid for? A list of persons. And, most important, how much did he pay? And then the method itself has 3 simple steps. So first of all, we increase the balance of the person who paid by the amount that was spent. We calculate how much each person in the paid for list is owed. So by dividing the total amount by the number of persons present. And then we simply decrement or decrease the balance of each person. And now we have settled our payment. And as I said, what is very important is that we don't create money. We don't want money to disappear. The balance should always be 0. And, well, as programmers, what is the best way to verify it than to write a test for it? And if we would normally write a unit test based on examples, then what I would usually do is, well, something like this. So I start, I use a Kotest framework for it. I start by initializing some examples. So we have Willem, we have Henk, we have Jan, some typical Dutch names that participate in this settling ritual that we have. Then, once we have set it up, then we call this method, so the settle payment method. Willem paid, and he paid for all 3. He paid 90 euros. Easy enough. And then the final step is always, what did I expect? And we assert, does it match with what we expected? Pretty simple unit test. And of course, when we're testing with examples, it doesn't stop here. We would need more examples, right? We want to have, for example, a negative amount, maybe a case where Willem pays for the others, but not for himself. Maybe he pays only for himself. Well, you get it, right? It's a whole build-up of examples, and in the end, you have this very nice, comprehensive test suite. And then when you press the execute button in IntelliJ, you think, hey, super nice. It passes. I thought about these examples very deeply. I understand my domain. This is covering the, this is representative for the cases that we can realistically expect. And then we're able to start and deploy. We can deploy our code to production. Everyone happy. Everyone can start settling their payments. But yeah, what could be a problem here in this example-based testing, as I call it? Well, fundamentally, we write a bunch of very similar use cases or very similar test cases that each just use a slightly different example. And that leads to some obstacles. So first of all, you need more development time. You need to write out more code, but also you have to think more about which examples. What are the examples? Am I now covering the stuff that I want to cover? Is it complete? Will take you time. And also more lines of code, it means more maintenance. You have to think every time you make a change, you think, okay, the examples that I have, do they sufficiently cover the functionality that I am testing? Also, it's not immediately clear if you look at the whole class, the testing class, what am I intending to test? If you have a new software engineer joining your team, they are faced with this whole list of examples. But yeah, it will take a bit before he realizes, okay, with all these angles, this is actually what I want to test. And even though we have quite some code written, actually, if you think about it, we have only a very small portion of all possible examples covered. In the testing that we just saw, we are always talking about our Willem, our Henk, our Jan. But yeah, that's just a very small part of the total possible values. And it still gives us kind of the impression that when it passes, it will pass for other values as well. And then the last part, there's also a certain amount of coupling, for that same reason actually, a certain amount of coupling between test and example. We're always using Willem, it's always the same email address, and we think, okay, doesn't matter if next time Maurice or Alexander comes and registers, it's just a name, it doesn't really influence it. Still, we're always using these same few examples for our tests. And these problems, I've thought about them a lot. And actually the root cause that I think what causes this is the following. Is that when we have our method with the parameters, then we write code that is generic and not example specific. We write in terms of these parameters. But then when we start testing the code, we actually write tests that are example specific, but not generic. So the tests and the code, they actually live on different levels of abstraction. The tests are just more concrete than the actual logic. So naturally, the question then becomes, what if we could write tests on the same level that we can write our code? And well, you can expect this is where property-based testing will come to the rescue. I think that property-based testing as a complement to your test capabilities can, in a lot of cases, alleviate the problems that we just saw before. Then, what is property-based testing? What is it? How do we use it? What is it? What are its concepts? Well, let's have a look. So here we see the test that we saw earlier from the example-based testing again. It starts with examples, and we just said we're done with examples. We don't want to tie it to examples anymore. So what we do first is we put a big cross through all these examples, and we just delete it from the code base. Now we have this blank space where we can do our property-based testing stuff. And what is this stuff? It's actually that instead of us as developers declaring concrete values, thinking of the examples ourselves, we leave it to generators. So in Kotest, the framework that we're using, you have ARB. ARB stands for arbitrary. And ARB has a lot of built-in generators for a lot of common data types. So here you see, for example, numeric float with a certain range, but also a non-negative integer. It also has some more custom things like a first name or an email address that it can make, even ice cream flavors. I don't know who did that pull request, but I never used it in practice, actually. So we leave the generation of the examples to the framework. And then, of course, we were talking in terms of persons, right? So we do need to add some transformation code where we round the amount to 2 decimals because, well, cents. And also we map the number of persons, we map to actual persons. And we also use some extra additional generators based on our first generator. So you can kind of compose them together. But the rest of the test, it actually stays the same. And then the cool thing is that when you run this test by Kotest, then it will automatically run it 1,000 times. Although you can also set it to, for example, 1 if you were just doing like TDD style development, that you don't want to do 1,000 tests every time. That would be a bit slow. But this is really it. This is a property-based test that just works. You decouple the examples that we saw, and you leave that to the framework now. So what you might think, we just replaced it and we said, okay, you come up with the examples, but we already tested the feature before, worked perfectly with the things that we came up with. So, ready for launch again, right? We can go to production, code stays the same, good. But actually, this time, when we let Kotest generate examples for us, suddenly the test is failing. Okay, so now the test is failing. It was randomly generating examples, so actually we have a bit less information than that we had before with the example-based test, when we exactly were consciously testing a certain example. Lucky for us, property-based testing has another very important superpower, and that superpower is called shrinking. Shrinking. So what is it? Yeah, shrinking is that the generated values, so in our case the float and the integer, it will shrink them. So for example, well, let's just look at an example actually. So let's move over to IntelliJ. Here's IntelliJ, I just copied it. The stack trace, and what it says is, hey, my property-based test failed, but it failed on these examples. So the float was 77, blah, 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 blah. And the integer that I generated was 4, and then the test suddenly failed. And the reason that it failed is that, well, I was expecting the balances to sum up to 0. As we said, no money created, no money disappeared. But actually, there was a very, very, very small deviation. 0.00038, etc. Okay. Now, the shrinking mechanism of property-based testing kicks in, and we can start exploring what actually happened. So if you scroll down a bit further, then you see attempt to shrink the first argument. And for floating, so this shrinking behavior is defined for each data type individually. For shrinking, for floats, shrinking means that every time we cut off one of the decimals at the end, then we try again. If the test still fails, we cut off another one, blah, blah, blah. And at some point you see, at the fourth attempt actually, 77, suddenly it passes again. 10 minutes left, okay, cool. I have to speak a bit faster. So I will just give you the clue instead of letting you think about it. The answer is, of course, it's a float rounding error, right? We were using a float, it has a certain precision, and when you then change all these balances, then you could have an issue that you get a tiny deviation because it doesn't fit the precision of the float. And that's what explains the 0.0003, etc. But property-based testing doesn't stop here because it had two parameters this time. So we scroll a bit further down, and we've already found this one. It now starts doing the integer shrinking. Now you would expect that when shrinking an integer, it would just decrease it by 1 every time. And that is actually true. But what Kotest does, it's actually funny, well, kind of funny behavior, kind of cool. In 98% of all cases, it will just shrink as you expect, so decrementing it. But in 2% of the cases, instead, it will go to an edge case. So for each data type, the generator also defines what is an edge case. And for integers, that would be, well, for example, a 0. It would be max value, for example. So in this instance, it just jumped immediately to the edge case. And it gives us a completely different error, actually. Quite surprising. Maybe not if you saw the code before. But now we have an issue that it says the collection is empty. Now, we'll give you the answer on this one as well. The paid for list, we expected it to be filled with the people that you paid for. But if you would try to cheat the system and pay for no one, then in this case it would actually throw a bug, an error, which I think is, well, probably the best error outcome that could happen, because the alternative would have been that it just went through with it, increased your balance, and decreased no one's balance, and you would just have free money all the time. Depending on who you ask, that could be a nice feature, but I don't think my friends will be very happy with me. Although it might explain why I'm on the top of the balance list, right? Anyways, what we see is that even though we thought before with the example-based testing that we covered a sufficient number of cases, actually when we leave it to the framework, when you say, hey, we're just expecting this data types, you take care of it, it already found 2 bugs for us. And that will help us make our code more resilient again. And the cool part is, next time we run it, it will come with 1,000 other examples. Maybe you discover something new, but at least it will help you make your method more robust outside of our beloved Willem, Henk, and Jan. Now, this is kind of practical introduction to example-based testing, but did it actually solve our problems? Now, these were the problems that we mentioned at the start of the talk. I guess it will alleviate you from writing much test code, because all these examples, they are now compounded into a single test case where you just define generators. And you totally don't have to come up with examples anymore, right? You don't have examples. Well, that follows from it, I guess. The lines of code, it's also decreased. It's now a single property-based test case. It's probably easier to maintain. And you also don't have to update your examples when your requirements change. The tiny portion covered, we also solved. There are no explicit examples anymore. It will be another one every time that you run it. So actually you'll eventually cover the whole domain. And at least every time you explore 1,000 times more than what you would normally explore. Coupling between tests and examples, it's also gone. Because there are no examples anymore, so you cannot couple to it. But the last thing, I find it a bit doubtful. Because if you look at the test that we saw earlier, this whole part that we added, I wouldn't call it intuitive, right? The fact that we generate a float and an integer, it's kind of a technical means to declare our examples, which are actually the euro and the persons. So yeah, this is not that much more readable, but luckily for us, we have the power of Kotlin, we have extension functions, and we have Kotest, who's offering us to make what they call custom generators. So let's have a look at that. They could look something like this. So you declare just an extension function. Ah, nice. You declare just an extension function on the companion object of ARP, so that you can call it on the class. We have a person generator, and we'll also make a money amount. And this is actually an ARP of the type person and euro. And we can encapsulate the logic of generating it by using the ARP builder that is built into Kotest. So you see arbitrary curly brackets. And then a really cool feature there is that Kotest allows you to compose generators from other generators. So in the case of person, we actually use 3 other generators that are built in. We call the bind on them to get a value from them. And then we use it to make this higher order generator for persons. And you can go on and on. At some point, you can use person again in another class, etc. Now, we only have 5 minutes left, so I will not go deeper, but what is very interesting to check out is this arbitrary builder. It has a lot of different features to configure. One most prominent one is the shrinking behavior, because what you saw is that for float, it knew what to do. And for an integer, it also knew what to do. But yeah, how do you shrink a person? Well, I mean, you might know based on the domain knowledge that you have. You probably cannot let it to the framework to figure it out itself. So it has options for that, but also, for example, for edge cases. You can really tweak it to what fits your domain best. That's for another time. And you can also find it in my code examples, so don't worry. But by using these things, we can make the test much more readable. We end up with something like this. And now we just see check all money amount and list of persons, and the rest just stays the same as we had. So we actually decreased the lines of code from even a single example-based test. And we also don't have to read through all the examples anymore, because just like with normal methods, you just read the test in terms of parameters, basically. And that solves our final complaint, right? You can just look at the test. You can see it on the same, I would call it abstraction level as your methods. While at the same time, actually, you have less code to maintain. You automated one extra part of your task, which is thinking about all the domain knowledge that you learned and codifying it into all the examples that you want to write. While at the same time, property-based testing allows you to cover much more examples, the whole domain, basically. And with that, hopefully making your methods a lot more robust. Now, if you might think now, okay, let's throw generators at everything. I wouldn't recommend that. I think that this has its use cases. It's not, to use a cliche term, it's not a silver bullet. What we saw with the test just today is that it tested a certain property, right? The balances, it's kind of an invariant. The balances should always add up to 0, for example. In those cases, or when the outcome is actually very much dependent on only the inputs, then this is really suitable and it can really give you benefits. Sometimes you just have a method where the output is, well, if you would have to make it in the test, then you would basically re-implement the method in your test case. For those cases, I will just keep to examples, but at least it's another tool in your arsenal to use and to test your code. And I would like to leave it at that, because I only have 1 minute left. So thank you. Sorry? Oh, well, let's have 1 minute even. Then thank you so much, but let's stay in touch. This is the repository where you can find the examples that I used today, and also some extra ones that didn't fit this 25-minute talk. Before I thank you, I would like to request something for you. because, full confession, this is my first conference talk, a very special moment for me at least, and I would like to make a small selfie to send to my girlfriend, because she has been stalking me on, how did it go, how did it went? Hope you don't mind. I will do it anyway. And please say something like, Kotlin! Wait, I have to tilt the camera. Okay, Kotlin! Hey! Hey! Thank you so much for attending. Please look me up. I don't think we have time for questions. Look me up for a coffee. Let's discuss and see you around.